Hi guys, hope you all are doing good. So in the previous video we have learned how to insert a node at the beginning of a linked list. So in this lecture we will learn how to we are going to learn another important operation, that is insertion at the end in a linked list. So let us understand it in a very simple way. So without any delay, let's begin our today's lecture. Suppose we have a linked list. Suppose let me write. So we have linked list 10, 20, 30 and 40 and null value. So now we want to add another new node containing 50. So the final linked list should be 10, 20, 30, 40 and 50 and the null value. So how can we do it? So let us learn it. So think about a train. Suppose a train has three coaches. Suppose this is coach 1 and this is coach 2 and this is coach 3. So a new coach arrives. So where should we attach it? So so obviously we are going to attach the at the end of the train. So but first we need to, we need to must find the last coach. So then we need to connect the new coach. So linked list work exactly same. So before inserting the before inserting the coach at the last of the train, first we need to know the last coach. So in this scenario C3 is the last coach. So when we need to add the fourth coach, means first we need to know the last coach. So then we can add the fourth coach, and later on this last will be updated. That means now this fourth will be the last coach. So the same way the linked list work in the same way. So in the first step we are going to do create a new node. So we are now creating a new node. So now we have successfully created a new node. So in the second step, we are going to store the data. So let me write the code to store the data. So we have successfully created the snippet code for us to store the data. So why we need to give the null value? As you all know, because this is the new node will become the last node. So this new node 50 will become the last node. That's why the new next will be, new node next will be null value. So the current situation it will be like 50 that next to the null. So on the third step, we need to find the last node. So we need to start from the head value. So let me write the code. So first we need to write struct node start temp. We need to use a temporary variable to know the head value. So initially that temp equal to head. So now temp points to the first node. So we are going to use a loop. So we are using while loop. So let me write the code. So while temp next, we are writing that temp next is not equal to null. So this while loop continues until the temp next is not equal to null. The temp will be updated. So temp equal to temp next. So this is the code to for our loop to. So this loop keeps move until, this loop gonna move until the last node is reached. So let me take an example. Suppose the example is 10, 20, 30 and 40 and null. So this is our example. So initially temp points to the 10. So initial temp equal to 10, and later on it moves to 20, and later on it moves to 30, and later on it moves to 40, and it gonna stops when it gonna reaches the null value. So now we need to connect the new node. So now we need to connect the new node. So now the temp next, temp next, it becomes temp next equal to what it gonna become? Yes, it gonna becomes new node. So it gonna becomes new node. So now it gonna be 10, 20, 30, 40 and 50 and null. So we have inserted successfully. So insertion is completed. The most important line is this line is very important. So temp next equal to new node. So this connects the last node to the new node. So now let us dry run it. So initially, let us take a small example. Suppose initially the linked list is 10, 20, 30, and null. So this is our initial linked list. So now we need to create a new node. So we are creating a new node, new 40 equal to new node. So we are going to start the traversal. First temp equal to head. So as I written here, first temp equal to head. So on later on, temp moves to the 10 and moves to the 20 and moves to the 30, and it gonna stops at the, it gonna stops at the 30. It gonna 30 next equal to null. So stop the, we are going to stop the loop because 30 is the last node. So we have got the 30 is the last node. So now we are going to connect. That means we need to write again temp next. So temp next equal to what? So you are guessed correctly. It gonna becomes new node. So the now the final linked list will be 10, 20, 30, 40, and a null. So we have done. So now let us see the complete program. Complete C program to insertion the node at the at the end of the linked list. So let me move to the next page. So I have written the code already successfully here. So without any delay, let's see the C code. So these two header files are important, you all know. So I don't need to tell again, I think. So this we have created a node. So struct node, int data, struct node star next. So this is our, this is our node. We are using the structure, we are declared the int data and struct node. So in the main function, we are declared struct node head, second and third, and the new value, new node. So we are declared head and we are allocated dynamically. So I have copy paste just here for the second and the third, and I have given some values, head data 10 and head next equal to 10. I think everybody up to here is everybody clear. I in my previous videos also I have written same up to here. So here again, here is the comes the tricky part. So we have written the new node. Again we allocate the dynamic memory. So new node, so we allocate dynamic memory. So new node data equal to 40 and new node next equal to null. So we allocate the new node. So we need to move the temporary value. Using the temp, we are moving the head value. So we have used the while loop here. Temp next until it not equal to null. So temp equal to next and next until it gonna becomes the null value. So temp next it will becomes new node. So temp equal to head. So it gonna becomes like that. So temp equal to head. So again, while temp is not equal to none, so this is used to print the linked list elements. So finally we'll get the output 10, 20, 30, and 40. So let me ask some questions in this C code. So why do we traversal here? So we need to traversal because we must find the last node before connecting the new node. So what will be the time complexity? So in this scenario, the time complexity will be, let me write in the blue color. So the time complexity of this code is big O of n. So why it's big O of n? So when you see clearly in the insertion at the beginning, the time complexity is big O of 1. In the insertion at the end, it big O of n. Why it is? And actually, in the beginning, you can easily slot the first element because it needs only one operation. We need to add just in the beginning. When it comes to insertion at the end, we need to traverse the entire array. It takes a lot of time. That's why it's a big O of n. So that's the reason. So why is insertion at the end slower than insertion at beginning? So because insertion at beginning directly updates the pointer, as I mentioned earlier. Insertion at the beginning we can directly update the pointer. So but in the insertion at the end, we need to first requires a traversal. So this is all about about the insertion at the end. So let us revise quickly. First we have created a new node and we stored the data and set the next to the null, traversal the last node, connect the last node to the new node, and later on we connect the last node to the new node. Insertion is successfully completed. So we have successfully completed insertion at the beginning of the linked list. So now creating the nodes, traversaling nodes, insertion at the beginning, insertion at the ending. So in the next video, we are going to see we are going to see deletion at the beginning in the linked list with complete code, dry run, and interview questions, and with easy explanation. So I hope this lecture is clear to everyone. If you have any doubts, you can ask in the comment section. So thanks for watching and see you guys in the next lecture.